Hi guys, in this video we're going to talk about growth and decay functions. Growth and decay functions are exponential functions. The form of exponential functions are f of x equals a times b to the x. In the past we learned that linear equations or linear functions has the form of f of x equals mx plus b, and quadratic functions has the form of f of x equals ax squared plus bx plus c. Today we're learning about the form of exponential functions, which is f of x equals a b to the x. Now, in this form, a and b are the parameters of exponentials and are represented by real numbers. A represents the initial value, and b is the exponential factor. Exponentials can represent growth or decay. When b, which is the exponential factor, is greater than 1, we have a growth function, and b is called the growth factor. When b is a value between 0 and 1, we have a decay function, and b is called a decay factor. This is what a growth function looks like. And this is what a decay function looks like. Let's take a look at our first example. Identify the parameters of the exponential function and identify if it's growth or a decay function. Our first example is f of x or g of x equals 3 times 0.7 to the x. So this is an exponential function in the form of f of x equals a times b to the x, where 3 is the initial value for the function and 0.7 is the decay factor because 0.7 is a value between 0 and 1. Let's take a look at the second example. H equals 0.5 times 6 to the x. Again, this is an exponential function in the form of f of x equals ab to the x, where we have 0.5 is the initial value and 6 is the growth factor since 6 is the number greater than 1. Growth and decay factors can also be represented by rates, where we have the letter R represent the growth or decay rate. When we have an exponential growth, R is called the growth rate, and the equation is f of x, or the function is f of x equals a times 1 plus r to the x, where 1 plus r is the growth factor. When we have an exponential decay, that means r is the decay rate, and the exponential can be written as f of x equals a times 1 minus r to the x, where 1 minus r is the decay factor. So growth and decay can be represented by factors, or it can be represented by rates, and sometimes also growth and decay can be represented by percent. And to be able to work with percents, all we need to do is to change the percent to rates by dividing the percent by 100. So we can change percents into rates by dividing by 100. Now let's take a look at this example. The value of Jim's investment is increasing by 4% each year. If his initial investment is $1,000, determine the following. What is the initial value? So in this example, the initial value is $1,000. What is the rate? And we said that rates can be also represented by percent. So when we have 4%, that means we have 4 divided by 100 as a rate, which is 0.04. So the rate in this case that is represented as a percent is 0.04. What is the growth factor? We know that the growth factor when we have a growth rate is 1 plus r, or in this case 1 plus 0.04, which is equals to 1.04. Write an equation which could be used to determine the total value of his investment after X years. We know this is an exponential function because we have a growth rate. So my function is going to be f of x equals a is the initial value, which is 1,000. B, which is in this case, is the a growth factor, which is 1.04 to the x. The total value of his investment after 10 years. That's when we have x is 10. So we substitute x with 10 and we evaluate the function. We have equals 1,000 times 1.04 to the 10, and we find the answer.